So I wanted to make a quick video clarifying how we can use these formulas for gear ratios for sprockets and pulley trains as well. So let's go ahead and start with a sprocket system like we would see on a bicycle. So let's go ahead and draw this system here. We can get ourselves a quick circle. Let's make that a little thinner. I don't know why it's so thick. And then over here off to the side we can do a second gear, and then we can connect it with a hypothetical chain. And as you can see in this system over here on the right, we've got teeth. And so sprockets are very similar to gears, just using a chain to spin together. You can kind of see how they would spin together in the same direction. But other than that, other than the fact that the teeth aren't meshing, that they're connected by a chain and they turn in the same direction here, there's really no difference between gears and sprockets. And so let's call this sprocket here on the right, let's call it sprocket A, and let's call this sprocket over here on the left, and the sprocket here on the right, the one in red, let's call it sprocket B. And let's say sprocket A has a diameter of, well, let's go ahead and say diameter A equals 6 inches. 6 inches. Let's say diameter B, I'm going to have to draw this one on the outside here. Let's say diameter B is 2 inches. And let's say the torque at sprocket A, let's say that's 18 pounds, just to keep it simple. Well, then what would be the torque at sprocket B? And what would be the gear ratio, or in this case, I suppose we could call it the sprocket ratio in this system? Well, we could set the gear ratio, we could set that equal to, well, that's just gear ratio of A to B. So A is green and B is red. And I'm going to set that equal to the diameter output divided by the diameter input. So what's the diameter output? Well, the output here is what, 2 inches? So I'm going to say this is 2 inches. And the diameter input, let's say, is 6 inches, because that's what we're looking at here. And so this gear ratio is 2/6, or we could say is just 1/3. And so to find the torque, what I could do is I could set this gear ratio, this diameter gear ratio, I can set that equal to the torque output over the torque input. And so, well, what is the torque output and what is the torque input? Well, we know the torque input is 18 pounds. We said that in the beginning. And so I put 18 pounds on the bottom. And we don't know the torque input, which we'll call torque of sprocket B. And so to solve for this, we'll cross multiply and divide. 2 times 18 is 36, divided by 6, and we get a torque output, torque output of gear B, or sprocket B, I should say, since it is a sprocket, although we can call it a gear if we want to. It wouldn't really change anything. But the torque of sprocket B is 6 pounds. And so as you can see, sprockets work the same. And we can see also that pulleys, like this pulley train that you might see in an engine, also works the same. So let's go ahead and sketch this for ourselves real quick. Let's go ahead and get our circle tool out again. And let's go ahead and start with a yellow. And let's pair that with a little bit smaller blue. And let's put it also in this system. Let's put a smaller, even smaller orange. And let's call this pulley A. Let's call this one, not pulley A, we already did A. Let's use X. Let's call it pulley X. Let's call this one pulley Y. And then, of course, the small one we'll call pulley Z. And so let's say this one is, well, let's pick the right color here. But let's say that I went back too far there. Let's say pulley X is 5 inches. Let's say pulley Y is 4 inches, just to keep it simple. And let's say pulley Z down here, let's just keep it simple. Let's call this one 2 inches. And lastly, let's run a serpentine belt through the system. You can see some go over, some go through the middle. And so let's go ahead and draw us a quick serpentine belt. Let's say it's wrapping around X. It hits Y on the outside, or on the inside, then it goes around Z, and then it reconnects. And so let's talk about what's happening here. Well, as this belt spins through this system, it turns each individual pulley. So that will be happening here as well. As X is spinning clockwise, so let's go ahead and label that. It's spinning this way. It's spinning clockwise. Well, if you look, that's going to push this pulley. Let's go ahead and label that. It's going to be pushing this, I should say, belt downward. And as it's spinning downward, that will turn pulley Y. That will be spinning it counterclockwise. And so then the belt will still be spinning sort of down, and it'll be coming down and to the left. And if you look, that would of course be spinning Z clockwise again. And the belt keeps going around. It goes back up and around, and I can draw that better. And so you can kind of see how this system sort of works continuously. And the only real difference here is whether it's turning clockwise or counterclockwise, because the formulas would be the same. For example, the formula, the gear ratio between Y and Z would be 4/2. It would just be a gear ratio of 2 because it's twice as big. It would follow the same formula. The only difference is the pulley system doesn't have any teeth. So we wouldn't use the number out over the number in. We would just use the rest for the pulley system. And that's the only difference between a pulley system and a gear system, or a pulley system and a sprocket system. A sprocket system also has teeth. And so the only difference is that a sprocket system has the two gears turning clockwise. Well, it has them turning clockwise together if it makes sense. Actually, we could replace these two. We could say this is a pulley and this is a sprocket, and it would work the same, except again, the pulley system will lose its number of teeth as a part of the ratio system because pulleys don't have teeth. But let's go ahead and write that out. First off, let me move these up so I can have some room to write below, so it would look more realistic for our notes. But let's write this out pretty simply. Let's just say, basically sprocket systems, sprockets, and pulley trains, I should say pulley train ratios, work the same as gear ratios.